Hello grade 10 students. Welcome to another virtual class. I am Miss Madhu Vadge. In today's video lesson, we will perform another activity, linear equations with two variables. Through this activity, we are going to understand the method of graphical solution of pair of linear equations and hence establish the conditions for consistency. We have already studied this concept in the chapter pair of linear equations in two variables. So this video lesson will be like a revision class and a practice session for finding a graphical solution for given pair of linear equation. The aim of this activity is to obtain the conditions of consistency for a pair of linear equations in two variables by graphical method. The word consistency here means whether the given pair of equations have solution or not. If the pair of equations have solution, we say that they are consistent. And if the pair of equations do not have solution, then they are non-consistent. To do this activity, you must know how to find a table of solution or solution points for a given linear equation, and you should also know how to plot these points on the graph paper. Also, you must know that a linear equation represents a straight line on the graph. To do this activity, you will need 3 graph papers, pair of scissors, glue and geometry box. Here are the steps of procedure for this activity. The first step is to reduce the given equation in its standard form, which is a1x plus b1y plus c1 equal to 0. Then for each linear equation, find out a table of solution of ordered pairs x, y. Each ordered pair x, y is a solution of this linear equation. And find at least 3 ordered pairs. As we know that the graph of a linear equation is a straight line, to draw a straight line we need at least 3 points. Repeat step 2 and 3 for the second equation in the given pair. That means you will find out a table of solution for the second equation as well. Then plot the points that you have obtained for these two equations on the same graph paper. And draw the line and label each line with the corresponding equation. Then you have to observe if these lines are intersecting, parallel or coincident. Next step is to repeat all these steps for the second and the third pair of linear equations that are given in this activity. After completing the graphs, for each pair of equation find the ratios a1 upon a2, b1 upon b2 and c1 upon c2, and write your observation in a tabular form. Observe the results that you get and then deduce a conclusion. The first pair of linear equation is 2x minus 3y equal to 3 and 3x minus 4y equal to 5. For each equation, you are going to find out ordered pairs of solution x, y. For that, you will choose values of x and then find the corresponding value of y after substituting in the equation. To do that, first we will write this equation as y in terms of x. So this equation can be written as y equal to 2x minus 3 divided by 3. Similarly, the second equation will be written as y equal to 3x minus 5 divided by 4. Now choose values of x in such a way that the numerator becomes a multiple of 3, so that the value of y that you get will be an integer. Avoid getting fractions because it is difficult to plot fractions on the graph. So if I take x as 0, then the value of y will be minus 1. If I take x as 3, then 3 2s are 6 minus 3 gives us 3. 3 divided by 3 will be 1. Now recall, we have learned how to find out the third solution point without calculating. By just observing the increase or decrease in y with respect to the increase or decrease in x. So as we increase x by 3, the value of y increases by 2. So if we take the next value of x as 6, then the next value of y will be 1 plus 2, which is 3. We are able to do this because y is linearly related to x. If we have a quadratic equation to plot, then this method is not applicable. Similarly, let's find the points for the second equation. Again, values of x will be chosen in such a way that the numerator here 3x minus 5 becomes a multiple of 4. So if we take x as 3, 3 times 3 is 9, 9 minus 5 is 4, and 4 divided by 4 is 1. Let's take the next value of x as 7. So 7 into 3 is 21, 21 minus 5 is 16, 16 divided by 4 will give us 4. Now observe that we have increased x by 4, y increased by 3. So we can choose the next number for x as 11 and y will become 7. But let's keep the values smaller for x and y so that we don't have to use a bigger graph paper. So what we are going to do is subtract 4 from 3. So we get minus 1, and we are going to subtract 3 from 1. So we get minus 2. The value of x on the graph ranges from minus 1 to 7. And for y, we need to have on the positive axis values till plus 4, and on the negative y-axis we need to plot till minus 2. So accordingly, draw your axis. Let's plot the points for the first equation. 0, minus 1 will lie on the y-axis. 3, 1 lies over here, and 6, 3 is also in the first quadrant. Before plotting the points for second equation, join these points using your ruler and label the line with the corresponding equation 2x minus 3y equal to 3. Let's plot the points for the second equation. 3, 1 lies over here. 7, 4 is lying over here. And minus 1, minus 2 is lying over here. Join these points using a ruler. And label the line with the corresponding equation 3x minus 4y equal to 5. We observe that the lines are intersecting at point 3, 1. Likewise, you have to find the points of solution for these two equations. But first write each equation as y in terms of x. So y for the first equation will be equal to 4 minus 6x divided by 10. Now choose values of x such that the numerator is multiple of 10. So let's take x as minus 6. So the numerator will become 40, and 40 divided by 10 is 4. Let's take the next value of x as minus 1. So the numerator will become 10 and 10 divided by 10 is 1. Now observe that we have increased x by 5, then the corresponding values of y decrease by 3. So the third point can be obtained by adding 5 to minus 1. So we get 4 and subtracting 3 from 1. So 1 minus 3 will be minus 2. Similarly, write the second equation in terms of y. So we get y equal to minus 11 minus 3x divided by 5. Again choose the value of x such that the numerator becomes a multiple of 5. Let's take x as minus 7. So minus 7 into minus 3 is 21 and 21 minus 11 is 10. 10 divided by 5 will give us 2. Let the next value of x be minus 2. So on substituting, we will get y as minus 1. Notice that there is an increase of 5 in x. So the next number we will obtain by adding 5 to minus 2, that is 3. The corresponding value of y decreases by 3. So we are going to subtract 3 from minus 1 to get the third value of y, which is minus 4. Now the numbers on the x-axis will range from minus 7 to 4, and on the y-axis the numbers will range from 4 to minus 4. So accordingly we have to draw the graph. After plotting these equations on the graph, you will observe that this pair of linear equation represents parallel lines. Similarly, you have to find the table of solution for the third pair of linear equations given over here and represent them on the graph. So the third pair of linear equations represent coincident lines. After completing the graphs, draw this observation table and write down the ratios a1 upon a2, b1 upon b2 and c1 upon c2 for each pair of equation, and also write down the nature of the lines on the graph paper, whether they were intersecting, parallel or coincident. When the lines are intersecting, the pair of linear equation will have unique solution at the point of intersection. When the lines are parallel, there is no solution as these lines are never going to have a common point. When the lines are coincident, then every point of both the lines is a solution of this system of equation, and therefore we can say that it has infinite solution. So a pair of linear equations that has unique solution or infinite solutions will be called as consistent, whereas a pair of linear equation which has no solution will be called as inconsistent. Now let's link this understanding with the ratios that we have written over here. For the first pair of linear equation, we have got a1 upon a2 not equal to b1 upon b2. So when this condition is satisfied by the coefficients of x, y and the constants of these two equations, then that pair of equation will have unique solution. And this result can be generalized. Similarly, look at the ratios for the second pair of linear equations. We have got a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. So when we have this condition satisfied by the coefficients of x and y and the constants, then that pair of linear equation will have no solution. Observe the ratios for the third pair of equations. We have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So when we have two linear equations such that the ratio of coefficients of x is equal to the ratio of coefficients of y and is equal to the ratio of constants, then that pair of linear equation will have infinite solution. So these are the conditions for consistency which you will write in your conclusion. With this we come to the end of this video lesson. Your assignment for today is to complete this activity in your journal neatly. See you in the next class. Until then, goodbye.